Okay, in chapter 12, we're going to be working with three dimensions. It's called R3. R3 would be all the points in three dimensions. So let's get used to the three-dimensional coordinate system. In two dimensions, when you see y equal 4, you would think that's a horizontal line, right? Well, in three dimensions, you have the x-axis, the y-axis, and the z-axis. And so the xy plane would be the horizontal plane, and the z-axis would go up. So y equal 4, this 1, 2, 3, 4 would be the y-coordinate's always 4. So you look at this horizontal line here, but no, x and z can be anything. You end up with this plane. Doesn't look very pretty, but this is a plane that's perpendicular to the xy plane. This is the xy plane right here. So y equal 4 is a plane perpendicular to the xy plane that goes through the line y equals 4. Okay, how about z equals 6? Z equals 6, the z coordinate is always 6, x and y can be anything, so if you think of this xy plane here, the z coordinate is always 6, so x and y can be anything, so it's going to be a plane parallel to the xy plane that's 6 units up, right? How about y equals x squared? Now that would be a parabola in the xy plane, but since z can be anything, we get what's called a parabolic cylinder. We'll talk about that later. Notice in the xy plane you get a parabola, but since z can be anything, you get this shape. It's called parabolic cylinder. How about this one? You'd think this is a circle in R2, but in R3, it's a circle in the xy plane, but since z can be anything, you get what's called a circular cylinder, or what most people would call a cylinder. So in three dimensions, if you don't have a variable there, you allow it to be anything. Let's go back and talk about these planes a little bit. These are called the coordinate planes. The xy plane is this horizontal plane right here that's formed by the x and y axis. So the equation of it, since notice the z coordinate is always 0 on the xy plane. So the equation of the xy plane is z equals 0. Similarly, the xz plane is this plane coming out of the paper right here, xz plane, and the equation of that is y equals 0. The yz plane would be the paper itself, and so since x is always 0, the equation of the yz plane would be x equals 0. How about this? See if you can do this one. Find the expression for the region between the xy plane and the plane z equal 2. What would that be? How would you represent that region between the xy plane and z equal 2? Well, it would be a slab, wouldn't it? It'd be a slab, an infinite slab. So the z coordinate ranges from 0 to 2. X and y can be anything, so you just say z is between 0 and 2. The distance formula applies in three dimensions. So you can form the distance between 2 points in three dimensions by just taking the square root of the sum of the squares of the differences between the coordinates. So what would be the distance between these 2 points? Well, you just take 2 minus 1 squared plus 0 minus 2 squared plus negative 1 minus 1 squared. I believe you get square root of 9, which is 3. I like these problems. They're kind of nice. Find the distance between this point, 3, 4, 2, and the x-axis. So the x-axis is right here. When I say distance, I mean the shortest distance, okay? So the way you plot 3, 4, 2 is it's 3 in the x, 4 in the y, and 2 in the z. So you want to find, wouldn't this be the shortest distance to the x-axis? So you use the Pythagorean Theorem. It's the square root of 2 squared plus 4 squared. And so you get square root of 20, which is 2 radical 5. Don't get that confused with this. Look at the distance between the point 3, 4, 2 and the xy plane. Well, the xy plane is this horizontal plane, so I'm asking you, how high is this above the xy plane? You don't have to use the Pythagorean theorem there. That would just be 2, wouldn't it? That's the z coordinate. All right. Why don't you try this one? See if you can do this one. What is the distance from the point 3, 4, 2 to the x-axis? I should say the z-axis. We already found the x-axis. Find the distance from this point to the z-axis. If you think about it, don't I want to find this distance here, which is also this distance? So how would you do that? That's the Pythagorean theorem. It's the square root of 3 squared plus 4 squared, isn't it? This distance here by the Pythagorean theorem is the square root of 3 squared plus 4 squared, which is the square root of 25, which is 5. Nice. Try this one. What's the distance from this point, 3, 4, 2, to the yz plane? I should say xz plane. Find the distance from this point, 3, 4, 2, to the xz plane. This is the xz plane right here, isn't it? What do you get there? Isn't the distance just the xz plane? Isn't that just the y coordinate? This distance right here is the y coordinate, which is 4. There you go. Just like we did with the equations of circles in 2 dimensions, R2, we can form the equation of a sphere. We can define a sphere to be the set of all points in R3 whose distance from a fixed point is constant, and so we can derive the equation for the sphere. But this is what it is. So if I give you the equation, you should be able to complete the square and find the center and radius. That's not too hard. You just have to add 4 to both sides for the x's, 1 to both sides for the y's, and then you end up on the left side, you get x plus 2 squared plus y minus 1 squared plus z squared equals 10. So that would have to mean the center is negative 2, 1, 0. The radius is square root of 10. How about this one? How would you find the equation of the sphere with these 2 points on the endpoints of the diameter? Well, of course, there's lots of diameters to a sphere, and this graph isn't really accurate, but it's good enough for what I need it for. If these are points on the endpoint of the diameter, you need to find the center. The center would be the midpoint, wouldn't it? The midpoint, you add the coordinates and divide by 2. So I get this. And you also need to know the radius. We'll define the radius. Couldn't you just use the distance formula from the center out to the endpoint? So you use the distance formula from the center. So I would go, what would you get? 3 minus negative 1 squared plus 2 minus 2 squared plus negative 3 minus negative 1 squared. I get the radius as square root of 20. So the equation becomes x plus 1 squared plus y minus 2 squared plus z plus 1 squared equals 20. There you go. How about this? Find an expression for the region inside of this. Isn't this just a sphere centered at 0, 0? This is the unit sphere, right? So what would the expression be for the inside the sphere and above the x-axis? Inside the sphere. So this would be inside the sphere. Technically, it would be less than or equal to 1, wouldn't it? Wouldn't that be right? You have x squared plus y squared plus z squared is less than or equal to 1, because that would be everything inside of it. If you just had equals, it would be the sphere. Okay, so it would be x squared plus y squared plus z squared is less than or equal to 1. You'd also have to include the fact that z is greater than 0. All right, we'll see you next time. Bye-bye.